All right, we're going to be moving on now with functional groups. This is chapter 3. Here's a basic outline of the chapter. Uh, some of this I'll cover through my notes, some of it I'm just going to show you the book. But before you begin looking at chapter 3, if you haven't covered chapter 2 already, and I do recommend chapter 3 before chapter 2, however, there's a table in chapter 2, the pKa table, table 2.1, page 67. Recall Kas and pKas from Gen Chem 2. This is just a table of Ka and pKa values here in your book, table 2.1. It is missing something, so you really do need to put in H3O plus here after between HCl and CH3CO2H. Put in H3O plus, has a pKa of negative 1.7. Conjugate base is H2O. I'll put that in there too. I think it's a glaring omission by your authors, although I can see why they didn't do it, but I think they were wrong in that decision. All right, this table, you kind of need to memorize this table. We will discuss it a bit more, but anytime you need to memorize something, it's always a good idea to start early. So start early, memorize this table, note the types of molecules, the various functional groups, and that's what we're about to go into is these functional groups, the carboxylic acid, the alcohol. Memorize these functional groups and what their pKa value is. This table right here is one of the big keys of organic chemistry, of understanding organic chemistry reactions. The more you know about this table, the more sense organic reactions are going to make, the easier organic chemistry will be for you. So I recommend memorizing this table, these guys right here, and their pKa value. All right, that's table 2.1 in chapter 2. But we're going to go on with the functional groups in chapter 3, and they have their own tables to look at. So, for example, here is table 3.1 in your book, which is the table of hydrocarbons. These are molecules that are just carbon and hydrogen. Isn't organic chemistry easy? What do you call a molecule that contains only hydrogen and carbon? We call it a hydrocarbon. All right, but there is one problem that I don't care how technically right it is, your book gets wrong. An alkane is a molecule that just contains carbon-carbon single bonds and hydrogens, of course, single bonded to those carbons. No double bonds or triple bonds, that's an alkane. In generally, we say alkane has no functional group. There's no functional group here. Alkane is just the basic molecule. All carbon-carbon bonds are single bonds. No functional group. That I agree with. However, what most people call the functional group for a carbon-carbon double bond is alkene. Most people will say alkene is the functional group. If you have a carbon-carbon triple bond, we call the functional group alkyne. So with all of these tables in chapter 3, it's a good idea to just take the words functional group and write it over here. Alkene's a functional group, alkyne's a functional group, aromatic compound is the functional group. That's how most people describe functional groups. All right, but let's look at these. Alkane, we said no functional group is just carbon-carbon single bonds. Alkene has at least one double bond in the molecule, and alkyne has a triple bond. An aromatic compound, and we'll discuss this quite a bit more in Organic 2, has alternating double single bonds. So single bond, double bond, single bond, double bond, single bond, double bond. There are certain rules for aromatic compounds. It must have alternating double single bonds, and it must be a cyclic molecule, and must be completely on single double bond, single double bond, single double bond going through there. Which means if we were to draw this molecule right next to it, where we have a six-membered ring, and a double bond here, and a double bond here, this molecule is not aromatic, because we have double bond, single bond, double bond, single bond, single bond, single bond. We've got single bonds in a row here. This is not aromatic because you must be able to just keep going around the ring saying single bond, double bond, 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 single bond. You must be keep going. Here it's a double bond, single bond, double bond, single bond, single bond, single bond. Up, no, 2 single bonds in a row. To be aromatic, it must completely be alternating, and you have to keep going around. Double single, double single, double single, double single. Here it's double single, double single, 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 double single. Okay, not aromatic. Yes, aromatic. Okay. Ooh, while we're at it, when we're looking at carbons in our molecule, if the carbon is only bonded to one other carbon, we call that a primary carbon. Carbon bonded to one other carbon is primary. A carbon bonded to 2 carbons and 2 hydrogens, or just 2 other carbons, is a secondary carbon. A carbon bonded to 3 carbons is a tertiary carbon, and a carbon in the middle of 4 carbons, a carbon bonded to 4 carbons, is called a quaternary carbon. All right. So, primary, secondary, tertiary, and quaternary carbons. Note that we're going to see primary, secondary, and tertiary in other functional groups, and there's a slight difference. So, carbon bonded to 1 carbon is primary, 2 carbons bonded to a carbon is a secondary, 3 carbons is tertiary, 4 carbons is a quaternary carbon. All right. Table 3.2, we start getting into other functional groups here. The alkyl halide, alcohol, ether, amine, thiol, sulfide. And as I said before, where here it says type of compound, this is functional group. Everyone calls the ROH the alcohol functional group. What it is calling the functional group in your table, it says that this is the functional group up here for these guys. I'm calling it basically a piece or a part of the real functional group. Hydroxy isn't the functional group. Alcohol is the functional group because there are other compounds that have hydroxies in them, but they're not alcohols and they're a different functional group. So this is the functional group over here, and we will go through these in a moment. And then the next set that we're going to go through in table 3.3, all these functional groups, and this is the functional group here, not type of compound, this is the functional group, have a carbon double bond oxygen in them. This carbon double bond oxygen itself isn't really a functional group. You have to look at the things, the 2 things on either side of the carbon that contains a double bond oxygen. This group, just carbon double bond oxygen, is called carbonyl. This is the carbonyl group. And what makes different carbonyls make them different functional groups is the 2 other things bonded to the carbonyl carbon. All right. So, yeah, that's the deal. And by the way, this is how you spell carbonyl right here. So we've got functional groups with carbonyls in them. We'll see they are related to the functional groups without the carbonyls. None of these have the carbonyl in them. And then we had the just regular alkanes, alkenes, and alkynes, single, double, triple bonds. So let's take a closer look at these functional groups. And we've already discussed just the alkanes, alkenes, and alkynes. So let's look at alkyl halides, also known as haloalkanes. For example, CH3CH2Br. You just have a halogen bonded to a normal carbon, a CH2, an alkane-like carbon. And these alkyl halides can be classified as primary, secondary, or tertiary alkyl halides. All right. If we look at where the halogen is, we look at the carbon that contains a halogen. If that carbon containing the halogen is bonded to just 2 hydrogens on there, this is a primary alkyl halide. Okay. Uh, if that carbon containing the chlorine is bonded to two other carbons, this is a secondary alkyl halide. If the carbon containing the chlorine here is bonded to three other carbons, this is a tertiary alkyl halide. All right. Note, it follows kind of along with what we said about carbons. A carbon bonded to just one other carbon is primary, carbon bonded to two carbons is secondary, carbon bonded to three carbons is tertiary. Can you see we cannot have a quaternary alkyl halide? Because a carbon containing the halogen, the chlorine here, cannot be bonded to four other carbons because a carbon can only form four bonds. And one of them has to be to the halogen. So we've got this is a tertiary alkyl halide, secondary because the carbon's bonded to two carbon, primary, the carbon's bonded to one carbon. And when you're doing the line structures, recall that the line ends here, so that's a CH3. It bends here, so that's a CH2. And then it's drawn to the chlorine, so this is a CH2 bonded to the chlorine. For this molecule, here's its line structure. For this molecule here, we got a CH3 here, a CH3 here, and a CHCl here. And here's how we draw our tertiary alkyl halide, CH3. This carbon has no hydrogens on it, so you can see all four bonds coming from it. Two other CH3s, primary, secondary, tertiary, with our alkyl halides. Now, the next group is the alcohol functional group. And what makes it an alcohol functional group is that hydroxyl group, or that hydroxy group, the OH, attached to an sp3 hybridized carbon, attached to a normal tetrahedral carbon. That's what makes it an alcohol. CH3CH2OH, or you cannot put the dash in there, just CH3CH2OH. These are alcohols. You can even draw it, CH3CH2, line to the O, line to the H. Here's the line structure of it, CH3, CH2OH. Note that alcohols can be primary, secondary, or tertiary. These are all primary alcohols because the carbon that contains the OH is bonded to just one other carbon. Well, they're all the same molecule. The carbon containing the OH is bonded to one other carbon. So, question for you. What type of alcohol is this? Yes. We see the carbon that contains the OH is bonded to three other carbons. Okay, carbon bonded to three other carbons. That is a tertiary alcohol. Okay. While we're on the subject of alcohols, let's realize something, that in chemistry an alcohol is defined as any molecule that has a sp3 hybridized carbon with an OH on it, which means CH3OH is an alcohol. CH3CH2OH is an alcohol. CH3CHCH3OH, there's a nice secondary alcohol. Oh, but look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just put something there. This molecule is an alcohol. All three of these molecules are alcohols. However, in the general public, people don't know that. When people think of alcohol, they say, oh, let's go buy some alcohol. They're probably not thinking of buying this down here. When people say alcohol, now, oh, we need to take a step back. If you are not over the age of 20, if you are less than 21 years old, I'm sure you have no idea what we're about to talk about here. But assuming you are age 21 or over, then you have heard of things like beer and wine and tequila and things along those lines. A lot of people, when they think of alcohol, that's what they're thinking. Beer, wine, tequila, rum, that type of stuff. That alcohol is this one right here. This is known as ethyl alcohol, or ethanol. We'll get into how to name these in the next chapter, or ethanol. It is also known as grain alcohol because it comes from fruits and grains, corn, potatoes, grapes, agave plants, things like that. So this is grain alcohol. Most of the alcohol we get is from corns. Beer uses hops and barleys and things like that. This alcohol up here is methyl alcohol or methanol, also known as wood alcohol, because this is what you get if you ferment wood, such as boards or trees or the stems of plants. That's methyl alcohol, methanol, or wood alcohol. This one down here is isopropyl alcohol. And it's what you disinfect things with. It's also known as rubbing alcohol. Note, although these are all alcohols, they have very different things. Now, they all disinfect pretty well, but this is the only one that you can really drink. Now, you note you can't drink much of it. 375 milliliters of this is going to make you super, super sick. 375 milliliters of ethyl alcohol is the amount of ethyl alcohol you would find in one bottle, normal bottle of tequila or rum or vodka or something along those lines. So if you drink a whole bottle in one sitting, some people will die. Everyone will get super, super sick. So 375 milliliters of this is going to do some serious damage to you. Methyl alcohol will kill you after about 40 to 50 milliliters. 50 milliliters about the most any person can handle of methyl alcohol. 375 milliliters, 50 milliliters. And long-term exposure to low levels of methyl alcohol will make you go blind. Isopropyl alcohol, you don't want to drink that stuff. That'll just make you start puking up stomach lining and stuff like that. But it's something that happens, unfortunately, too often. People drink way too much ethyl alcohol, decide they need more ethyl alcohol, don't want to drive because they've been drinking too much ethyl alcohol, and so they say, oh, that's no problem. I've got a bottle of alcohol under the bathroom sink, the isopropyl alcohol. Then they start drinking that, and then they end up in the ER puking up stomach lining and nasty things like that. So know your alcohols. When you're talking about the alcohol of alcoholic beverages, it's ethanol and only ethanol. No other alcohol is the type you would put in a drink. However, to a chemist, alcohol just means you've got an organic molecule, you've got an sp3 hybridized carbon, and you got an OH on there. That's an alcohol. All right. Okay, we will continue. Let's continue with the next set of functional groups in the next video.